Any questions at all? So last time I defined complementary pairs. So we have the primal problem and the dual problem, and let me just show you the matrix form of the two problems. And how do we define complementary pairs between the variables, the primal variables and the dual variables? Well, the primal decision variables correspond to the dual slack variables, and the primal slack variables correspond to dual decision variables. And we are going to use the notation x to the c to mean the complementary dual variable of x. Okay. So this notation will be used later. And so x to the c would be ys, and s to the c would be y, right? So let's look one more time at the primal and the standard problem. Now the the primal problem, the dual problem that I have as a minimizing problem, I'm going to turn that into a standard form problem. So then the dual problem now will look like this. Okay. So all I did is the dual problem is written in the standard form. So that's why you have the negative B transpose Y for W now. So these are now we're going to concentrate on these two forms of the primal and the dual. Now let's look at the example we did last time. So if I have the primal problem z equals to x1 plus 2x2, and given the constraints in blue ink, and then we have the dual would be maximizing W, where I have the coefficients of the dual objective coming from the right hand sides of the primal functional constraints. And you have those constraints. We did this example last time, I believe. And then we look at their slack forms, right? So we write down the slack forms with the slack variables, and that's what we get. And once I have this, now I'm going to write down the complementary pairs. So the variable x1 will correspond to what? The variable x1 will correspond to the first dual slack variable. The variable x2 will correspond to the second dual slack variable, and so on. So those are the complementary pairs. And so now, so this is where we got last time, right? Am I correct? So again, you have a primal problem, dual problem in the standard form, and then you have this complementary pairs between the primal variables and the dual variables. The next thing that I want to look at is that why are we considering complementary pairs? Well, this is going to give us a correspondence between the primal dictionaries and the dual dictionaries. How? Let's say I have let's write down the let's write down the primal dictionary. So you may remember, this is the primal problem is in blue ink, and the dual problem is in black ink, and the slack form of the two are here, right? Now I'm going to write down the dictionary for the primal. So the primal dictionary will be what? And the dual dictionary, the initial dual dictionary, I wrote down both of them. Okay? So I wrote down the primal dictionary and the dual dictionary. So in the primal dictionary, these are the initial ones. Okay? These are the initial dictionaries for the two problems. And in the Primal dictionary, what are the basic variables in the initial dictionary? Well, the basic variables are basically the select variables, and then you have the right-hand sides of the functional constraints, and then you have the other variables there. And z is 0 plus x1 plus 2x2. And then I also wrote down the dual initial dictionary there. And I want to show you that there is a correspondence between the two. So what correspondence do I have here? Well, I have the same correspondence I have for complementary pairs. Notice a couple of, let me give you a minute here to finish up writing it down, and then I'll continue with the discussion. And let me know once you're done with it. Okay, so what's the correspondence between the two? Well, here is the correspondence, okay? Notice, if you look at the first of all, let's look at the non-basic variables in the primal. What are the non-basic variables in the primal? Non-basic variables in the primal are x1 and x2, right? Now, what are the complementary? What are the complements of x1 and x2? Well, the complements of x1 and x2 is what? y5 and y6. So notice that the non-basic variables in the Primal dictionary are x1 and x2, and the basic variables in the Dual dictionary are in the Dual dictionary, the basic variables are y5 and y6. Okay. Notice this is the complement of this guy, right? So if I look at these two, the complement of x1 and x2, right? The complement of the primal non-basic is will be dual basic. Am I making sense? The complement of the primal non-basic would be dual basic. Now, what are the primal basic? If I look at the primal basic variables, they are here. And what are the dual basic variables? Right there. And notice that the complement of x3 is y1, right? Complement of x3, if you look back, complement of x3 is y1, complement of x4 is y2, and so on. So the complement. So what are the dual non-basic? The dual non-basic is basically the complement of the primal basic. The complement of primal basic is dual non-basic, right? What else? Now look at the coefficients of x1 and x2 look at the coefficients of the non-basics in the objective row of the Primal dictionary. Where do they appear? They are appearing right here with negative signs. Okay, so if you look at the primal non-basic variables in the objective row and look at their coefficients, take the negative of their coefficients, that's becoming the constant column of the Dual dictionary. What else? What else can I say? Well, I could also say that if I look at if I look at 2, 11, 3, and 6, right? Where are they appearing? Well, they are becoming coefficients of the objective, if you take the negative of them, the negative of these numbers, if you look at the negative of the constant column of the Primal dictionary, the negative of that is becoming the coefficients of the dual objective row, right? Is everyone clear? So what else do I know? Well, look at the coefficients. Look at the coefficients of x1, the primal non-basic variables. If you look at the primal non-basic variables, look at the coefficient of x1. Where do you see coefficient of x1 appearing? The coefficient of x1 is, so if I look at the coefficient of x1, maybe let me use green. If I look at coefficient of x1, right, they appear where? Negative of them, negative of those numbers are appearing here. Right? Am I making sense? So what's the connection between, if I say, look at the coefficient matrix for the non-basic variables in the Primal dictionary, let's call that A. So A is the coefficient matrix for the non-basic variables. So what is A? A is 3 minus 1, 0 minus 1, 1, 1, negative 1, 0, right? And what do I have? What is the coefficient matrix of the decision non-basic variables in the dual dictionary? Well, that's what? A transpose with a negative sign, right? Am I making sense? So let me recap what I just said. What's the correspondence between the Primal dictionary and the dual dictionary? Well, in generally speaking, what is a Primal dictionary? Well, you have xb represents the vector of basic variables. So that's going to be equal to a constant column b plus some coefficient matrix A times the vector of non-basic variables. And then you have the objective row, Z is Z0 plus C transpose times the Xi. So Xi represents what? The non-basic, primal non-basic variables. And C transpose represents the coefficients in the objective row. Now, how am I going from the Primal dictionary to the dual dictionary? Notice that the complement of primal non-basic, the complement of primal non-basic is becoming, so the complement of primal non-basic right here, the complement of that is becoming dual basic, right? So this, I should call that a YB. So the dual basic is the complement of primal non-basic. Also, if you look at primal basic, the complement of that right here, that is the dual non-basic. The complement of primal basic is dual non-basic. What else? The objective value, the primal objective value is Z0. The dual objective value is negative Z0. Okay. What else? The constant column in the primal is the negative of the coefficients of the objective row in the dual. If I look at the coefficient matrix of the primal non-basic, then the coefficient matrix for the dual non-basic is negative A transpose. Okay. Is everybody okay with that? So if I have a primal dictionary, I can look at a corresponding dual dictionary. Now notice that I haven't talked about feasibility, right? I haven't said these. I didn't say that these dictionaries are feasible, right? All I'm saying, if I have a primal dictionary, I have a corresponding dual dictionary. Okay. Let me know if you're done writing it down. Then we want to do an exercise to make sure we understand what we have just said. And this is the example that I have here. And remember, we just did we started with this problem here, right? And we looked at the first initial dictionaries for the primal and the dual, right? Am I making sense? And we looked at the correspondence here, and then now I want to do one more. This is also a dictionary, another dictionary for the same problem, primal. And I want to write down the dual dictionary. Okay, maybe I should use black for that. Okay, go ahead and write down the primal dictionary. So, and I'm going to then write down the dual dictionary. First of all, before you write down the dual dictionary, there are a couple of things that you need to ask, right? What's going to happen here? What would be the basic variable? What are the basic variables in the dual dictionary? What are the basic variables? What will be the basic variables in the dual dictionary? Remember, you wrote down the complementary pairs before for this problem. So what would be the okay, how many basic variables do I have in the dual? How many basic variables do I have in the dual? 2. What are they? Well, I look at what? X4 complement, right? What is X4? So look at the primal non-basic, right? And take the complements of them, right? Look at the complements of the primal non-basic. So X4 complement was what? What was X4 complement? X4 complement was what? X4 complement was Y2. Right? So Y2. Okay, also, what is the other non-basic in the primal? That's X3. X3 complement would be Y1, right? Y1. Okay, so I'm going to have these are the basic in the dual, right? And then I have a objective row in the dual. What would be the objective row? What would be the objective value in the dual? It will be negative of the objective value of the primal. So it should be what? Negative 18, right? Okay, and then what's gonna? Okay, in the what are the non-basics? What are the non-basic basics in the dual? Well, I need X1 complement, right? I will have X1 complement, right? And then I'm going to get X2 complement. And then I'm going to get X5 complement. And then X6 complement, right? And I need to know what are the coefficients of them. Where are the coefficients coming from? The coefficients are coming up for the dual objective row. The coefficients are coming from where? The coefficients are coming from the primal constant column, right? So this column here. This column here will give you the coefficients here, but with negative. So you're going to get negative 3 here, negative 11 here, negative 11 here, negative 3 here. Okay? So let me write again what that is. W is negative 18 minus 3. What is X1 complement? X1 is Y5, right? X1 is Y5. What is X2 complement? Y6. What is X5 complement? X5 is Y3. x6 is y4. Is everybody okay? And I'm going to delete this row here because I don't need them. Okay, so I have that. Now, what would be the constant column in the dual? So what is the number here and what's the number here? Anyone? What number do I get for star? Where are they coming from? Well, they are coming from what? The primal the coefficients of the primal non-basic variables in the objective row, right? So it'll be what? Remember, we took x4 complement, right? So x4 complement, what's the coefficient of x4? Negative 7/3, so you're going to get 7/3 here. What's the coefficient of x3? Well, that's 1/3, so you're going to get negative 1/3 here. Is everybody clear? Now what do I have here? Now after that, what do I get? After that, what do I get? Well, I have this non-basics are y5, y6, y3, and y4, right? So let me write them down. y5, y6, y3, and y4. y5, y6, y3, y4. Now what number, what are the coefficients then? What are the coefficients in the first dual, in the first row of the dual? What are the coefficients? Where are they coming from? Coefficients of the first row of the dual. Where are they coming from? You look at the coefficients of x1 and take take the negative of them, right? So what would be the coefficient of not x1, sorry, coefficients of x4, right? x4 is the first non-basic, so you look at the coefficients there. So that negative 1/3, negative 1, negative 2/3, and 1/3. You take the negative of them, you're going to get positive 1/3, so that's coming from here. Then positive 1 coming from here. Positive 2/3 coming from here. And then negative 1/3 coming from here, right? Remember, that row is for x4 complement, so you get the coefficients of x4. And then the last thing would be, you look at the coefficients of x3, you get negative 1/3, 0, plus 1/3, plus 1/3, right? So that's the dual. That's the dual dictionary. That's the corresponding dual dictionary. Am I clear? Is everybody clear? The correspondence between primal and dual dictionaries. Okay. Now, one more example, but I want you to do it yourself and see if it matches my answer. Okay, go ahead and do it yourself. So this is the primal, by the way. We want to write down the corresponding dual. What's the dual dictionary? Okay, does anyone have the objective row of the dual now? What is that? 9y1 minus 6y5 minus 11y6 minus 8y3. Okay, so y1 is the complement of x3, y5 is the complement of x1, y6 is the complement of x2, and y3 is the complement of x5, right? y3 is the complement of x5, and so on. Okay, and then what is the complement of x6? What are the dual basic variables? I'm going to get the complement of x6. What is that? y4. And what's the complement of x4? What's the complement of x4? y2. Okay, what's going to go here? What are the constants on the right side? Someone else? What would be the constants on the right hand side? Or let's just read the entire row for y2. What would be the row for y2? What am I getting for y2? What should I get for y2? Yeah, 2 is coming from the coefficient of x4, and then you look at the coefficient of all the coefficients of x4, right? So what do you get? Negative 1 times y1. Let me write it a little bit up here, y1, and then you get plus 0 times y5. And then what else? Plus y6 and plus y3. The next one would be positive 1, and then plus 3y1, right? Plus y5 plus 0 y6 minus y3, right? Is everybody okay? Did you guys get the same? David? Okay. Now, so we have enough exercises, I hope, on given a primal dictionary, write down the corresponding dual dictionary. One thing that I want to, there are two claims that I'm making here, two general statements. If D is a non-final dictionary of the primal, then the corresponding dual dictionary is infeasible. Now remember what I meant when I wrote dual and primal in parentheses here. That is, you can replace the word primal with dual, and also the dual by primal is the second one, right? And you got a true statement. So what am I saying here? If D is a non-final dictionary of the primal, then the corresponding dual dictionary DC is infeasible, right? That's what I am claiming here. Can someone tell me why that's the case? Can someone tell me why that's the case? And also, the next statement that I'm making here is that if D is the feasible and final dictionary of the primal, then the corresponding dual dictionary DC is also feasible and final. Am I making sense? So someone give me an argument why the first statement is true. Why the first statement is true. Well, you have to look back into the two, primal and dual. You have to compare the two forms, okay? Look at the dictionaries for the two, the general dictionaries for the two problems, and figure out what happens when the primal dictionary is non-final. Then why is the corresponding dual dictionary infeasible? What's the meaning of infeasibility for a dictionary? Anyone has an argument for the first statement? Let me go back to the general settings of the primal and dual dictionaries. So this is our general setting for the two dictionaries, right? Now, what we are assuming in the first statement. In the first statement, I'm saying that the primal dictionary is non-final. What does it mean when I say that the primal dictionary is non-final? When you're applying simplex, right? It's non-final means what? Non-final would mean what? I'm sorry? Well, if you look, non-final means you can still increase Z, right? There is still a possibility to increase Z. What does that mean? It means that some of the coefficients in the objective row are what? Still positive, right? Some of the coefficients of the objective row, some of the coefficients of the non-basic variables in the primal objective row are positive. That's why you can still increase Z, right? So that means C has some positive entries, right? C has some positive entries. Well, if C has some positive entries, now then negative C has what? Negative entries. Well, then in the dual dictionary, negative C is the constant column. So that means in the dual dictionary, some of the basic variables are negative. Right? So that's why that dual dictionary is infeasible. So that's my first statement. If the primal dictionary is non-final, that would mean that some of the coefficients of the primal non-basic variables in the objective row will be positive, and that would imply that some of the basic variables in the dual dictionary will be negative. And therefore I have an infeasible dual dictionary. What's the second statement? The second statement is that if the primal dictionary D is is final and feasible, then the corresponding dual dictionary would have to be feasible and final as well. Is that the case? Let's look at that again. Final. The primal dictionary is final means what? All the coefficients of the primal non-basic variables in the objective row be what? Negative. Then I cannot increase Z anymore. Right? So C transpose is negative, that means C is negative. If C is negative, then negative C will be positive. Well, then all the basic variables in the dual will be positive, so it's feasible. The dual dictionary will be feasible if C is negative. And negative C will be positive. So, final primal dictionary implies feasible dual dictionary. Right? What else do we say? If the primal is feasible, what does it mean? If the primal is feasible, it means what? All the primal basic variables would have to be positive, right? So the primal is basic. Primal is basic means all the primal basic variables are positive. That would imply B is positive. If B is positive, then negative B transpose will be all negative. Well then, if you have all negative coefficients in the objective row, then you have a final dictionary, right? So feasibility of the primal dictionary implies that the corresponding dual dictionary is final. The fact that the primal is final implies that the dual is feasible, right? Am I making sense? Primal final means dual feasible, and primal feasible means dual final, right? Okay? Is everybody clear? Last thing. Remember that so this is the first picture that I have here is for primal, and the second picture I have is for dual. In the primal, for the primal problem, if I look at the simplex, algorithm, this is in the optimization phase. Okay, optimization phase. It doesn't have to be optimization phase. Sorry, it is. Let's say I have a primal dictionary D1 and another primal dictionary D2, and D2 is obtained from D1 by using the pivoting operation, right? In simplex, you go from one dictionary to another. So you're going from D1 to D2 by using simplex, right? And you are using a pivoting operation to get D2. Now let's assume that in order to get D2 from D1, xi is the entering variable, xj is the leaving variable. Okay? Is everybody clear? In order to go from D1 to D2, xi enters, xj leaves, right? Now what is D1c? D1c is the corresponding dual dictionary for D1. D2c is the corresponding dual dictionary for D2, right? Am I making sense? That what is the meaning of corresponding dual dictionaries? Well, we defined that before, right? Given a primal dictionary, we wrote down the corresponding dual dictionary. So D1c and D2c are like that. The question is, the way you got D2 from D1, how would you get D2c from D1c? Well, what happens is that D2c is obtained from D1c by doing the following. xj complement will be the entering variable. Remember, xj is the leaving in the primal. Then xj complement would be entering in the dual. And xi complement would be the leaving variable in the dual. Am I making sense? Remember, xi is the entering in the primal. Xi complement would be the leaving in the dual. Okay? Am I making sense? So all I'm saying is if D2 is obtained from D1 by using the pivoting operation where xi enters, xj leaves, then in the corresponding dual dictionaries, D2C is obtained from D1C by using a pivoting operation where xj complement enters and xi complement leaves. Okay? Clear? Now, a final comment here. Let's say I have the simplex optimization phase. So I'm looking at the simplex optimization phase for the primal problem. Okay? Simplex optimization phase for the primal problem. So what is happening there? I actually wrote primal below there, so I don't need to write it again here. Sorry. You start with a feasible dictionary D1, right? And then you apply simplex to get D2, D3, until you get to the final dictionary D star. So D star is my final feasible dictionary, right? And from D star, I can read off the optimal value for the primal problem, which I'm denoting by Z star, right? All the dictionaries in the optimization phase are what? Feasible, right? So all the dictionaries up to, let's say, maybe I'm going to write dn minus, or let me just say dn. All these are non-final, right? All the way up to dn, these are non-final dictionaries, and they are all feasible. Now let's look at the corresponding dual dictionaries. So what is happening in the dual world? In the dual world, if I look at D1C, D2C, all the way up to DNC, right? All the way up to D1C. Then what are these dictionaries? Remember, if you have a primal feasible dictionary, if you have a primal non-final dictionary, then the corresponding dual dictionaries are what? Infeasible, right? Remember we made a statement here. If a primal dictionary is non-final, then the corresponding dual dictionary is infeasible. So that means all the dictionaries in the dual world would be infeasible, right? However, what is the dictionary B star C? Remember, if B star is a final, feasible, primal dictionary, then the corresponding dual dictionary is also final and feasible, right? We just talked about that a minute ago. So B star C and D star, they are both feasible and final. However, what's happening in the primal world? Primal world, you start with a feasible dictionary and you go until you get the final. So all the dictionaries between D1 and Dn are feasible, non-final. But in the dual world, all the dictionaries up to D and C are what? Infeasible. Am I making sense? So there is something called dual simplex method. The simplex method that we used before, and then there is something called dual simplex method, which is basically using the dual problem to come up with the optimal solution for the primal. Why? Because if you look at the dual simplex, so whatever the final dictionary is, that from that final dictionary you can look at the corresponding final dictionary for the primal, right? And then you can come up with what's the relationship between the primal objective value and the dual objective value? Well, they are negative of each other. Why negative of each other? Remember I said at some point they are the same, right? But why am I saying now they are negative of each other? Because remember, whatever the dual minimization problem was, we multiplied that by negative in order to put it in the standard form. And because of that, now the dual objective value would be negative of the primal objective. If I keep the problem in the minimizing form, then they are the same, right? Is everybody clear? Any questions? No? Well, all the videos are up except for today's. During the break, you might want to revisit them and make sure you understand everything. The next topic that I wanted to do would be proofs. Remember, I didn't give you a proof of the strong duality theorem. And I also want to, well, for a long time now, I have dodged a couple of questions, which is, remember, we said that if I have a problem, linear programming problem, I use Simplex method. I use Simplex, and when we look at the optimization phase, we get to a final dictionary, and whatever the objective value I get from the final dictionary, that's the optimal value, right? However, I never gave you a reasoning why that's true. Why is it true that the final dictionary gives you the optimal value? Did we discuss that? No, I didn't tell you why. I told you sort of, okay, you get to the final dictionary, you cannot increase z anymore because of those negative and stuff like that. But that's not a proof. So why is it true that the final dictionary gives you the optimal value? And we can do that now by using this dual dictionary concept. And at the same time, I'm going to prove a strong duality theorem to you as well. But I guess I don't have enough time for that today. So I won't start it because I cannot finish it at the same time. So I will see you after the break on Tuesday. During the break...